Hey guys, so we'll see maximum product sub array. Okay, so uh, um, the last problem that we did was coin change, and it took me like forever, like for 2 hours straight. I was trying to find out what solution it might be. Like I was trying out different videos from where I can understand what's going on exactly in the problem and how can we solve it. However, after spending 2 hours straight or more than that, I I was able to solve the problem with the help of backtracking DFS, or like using DFS, where we go using using every possible coin n number of times until it reaches the amount. So yeah, that part I understood, but the DP part of it, it was just bouncer, uh, and I'm not able to wrap my head around. But you know what? We'll keep striving hard, and I guess my approach was to just finish off this list. So instead of that, I think I should change my approach and at least try to see what's going on, like how we can solve a problem of TP. And after spending hours and hours on these problems, it's the chances of coming in interview, I don't know what they are, and it's same for every problem that we have in this list. So you know what, prepare for the worst and hope for the best. So that's what we are going to do. We will see what we have here, and we will try to answer, like try to solve this question. So let's give it a shot. Given an integer array nums, find a subarray that has the largest product and return the product. The test keys are generated so that the answer will fit 32-bit integer. Gotcha. Maximum product subarray. So 2, 3 minus 2, 4. Given an integer array, find a subarray that has largest product, return the product. The test case are generated so that the answer will fit in a 32-bit integer. 2, 3 minus 2, 4 has the largest product. Subarray. Okay. So we have to find a subarray in which the product is more, right? Got it. So we cannot multiply the number by itself. Okay. So my first thought is, can we use a 2D matrix of a DP, and then how can we populate the numbers? So because the left hand side of it would be the start, and like left would be the start of it, and the topmost would be all the rows. So obviously we cannot go to 0 0. We cannot take that as or can we just consider 0 0, which is pointing to the same thing, to be the largest? So everything. Okay. And how about 0 2? When we compare 0 with 0 with 1, which in this case, let's so I so is that thought process correct? First of all, I don't want to jump straight into solving it and waste like hour about it. So let's see the constraint first. What constraint are there? So constraints are nums dot length is less than, greater than, equal to 1, and less than equal to, okay, and the value would be minus 10 to less than equal to 10. The product of any suffix of num is guaranteed to fit 32 bit. Okay, got it. So that's what our answer is, right? So the brute force approach of this would be every every so this would be multiplied by this, then the answer of this will be multiplied with this, and at every stage we'll be storing the maximum product that we can get out of it, and the sum of this all will be with this, then this will be multiplied by this, then this, that will be O of n square, obviously, as this, the length would be 2 into 10 raised to 4, and n squaring that, if we n squared it, then it will run out of, like, time will exceed. Can we bring it down to like n? Because doing a dp, like a dp of 2 raised to 10 also won't make sense, because we will be again traversing the entire loop. So what about single 1D array for this? So 2, 3, minus 2 and 4 is there, right? So how about if we okay, let me rub this first and then we can go about how we can, solve this problem. After I get a job, I will definitely invest in a good laptop in which, while streaming, I won't get such lag. There is a lot of lag. I don't know why is it, because I'm streaming. When I'm not streaming, it's just fine. Um, like it works super smooth. But when I'm streaming, it's too slow. My laptop gets too slow. So yeah, I need to fix that problem. But yeah, let's see here. We have this. What did we have? We have 2, 3, and minus 2 and 4, right? We had this. So it's better if I use my iPad. Okay, yeah, got it. So minus 2, 3. So dp, if we create a dp, then we assign So 0 1 2 3, right? So we create 1 2 3 4 4, a dp of 4, length will increase the length by 1. And then what we can do is, I'm just trying to so for 1 we can, like, till sub array 1, this will be the greatest one, right? The 2 will be the greatest one. So 2 into dp of 1 will give us the greatest value. What would be the maximum of this guy? 3. So 3 into dp of previous element. So what is num of I? We want to find the recurrence relation, right? Num of I into dp of I minus 1 is greater, or num of I is greater by itself. So we need to check that, I guess. So 2 2 ones are 2 and both are same, then 3 2s are 6. 6 is greater than 3, then we update 6 here. Then minus 2 into the dp of the last value is 6, it's minus 12, so we will keep as is the minus 2, and 4 will keep as is. So on the fly we can always capture this. So yeah, this works, but we want to make sure that it works for all the cases. So let's take minus 2 0 and minus 1. So I'll do it right here, minus 2 0 and minus 1, and we'll create a dp. So here, so we have to create a dp of this. So minus 2 is greater than 1. No. So nums of I into dp dpi minus 1 is greater. No. So we'll keep minus 2 as is, and then 0 comes in, 0 gets multiplied, so 0 is obviously greater, so 0 will keep as is, and then minus 1 comes in. Okay. Okay, I think this should work, but let's see. Let's try to implement it. It's here, right? Let dp is equal to new array nums dot length plus 1, and dp of 0 is equal to 1. We'll set it to 1. Then what we need to do is, for let I okay, dp I is equal to 0, I is less than nums dot length. We gotta do this until we reach the end of this. Then We also need to keep the max product, right? Let max is equal to, so we want to set it to number dot minimum of safe math dot max. We have to update the max, right? So what we are doing is TP of I, which is current one, or else what we can do is we can do this with respect to dp dot length, right? Dp dot length, and let's start it with 1. So dp of I equals to, what was the formula? Nums of I minus 1. So is it equal to nums of I minus 1 into dp of I, right? I minus 1. Which one is greater? So math dot max, yeah, so that's how we'll get dp of I. Then yeah, and is max greater or dp of I is greater, simply. And we can return max in the end if everything goes well. Okay, yeah, so this worked, and let's submit it. Okay, so that's a good start. We this little algorithm was able to solve 109 uh, test cases out of 190, so that is a good start. And we are just running of n times, and the space complexity is also O of n. So number means safe integer. Okay, what, so minus 2 3 4. Okay, here my logic went wrong. So if I multiply minus 2 with 3, so how should I consider this? Should I be drawing 2D matrix for this? 3 2s are minus 6. So should I be storing that in dp of I? Okay, so in this case, yeah, like when everything is, in this case we definitely need to do something about it. How can we go about changing something here which will help us to deal with such situation where, so right now we were just dealing with like what is the maximum. So what if I also keep one more array which keeps track of minimum, and that minimum then that minimum then is also passed to check if it gives us any maximum value. Will that work? Okay, let's call this db max, and let's call this dp min. Then we'll set both of them to 1. Then let min is equal to number dot max. So we don't need to worry about this, but dp max dp of max. So here let us zoom in a bit, and here we are dealing with what? Here we are dealing with maximum number. We are trying to find max. Okay, but before that we need to find minimum. So dp of min of I is equal to math or will it just store a dp of I? We can just store the simple calculation of nums of I minus 1 into dp min I minus 1. Okay, so yeah, that's what we will do. And then finally at dp min of I, so in case of -2, 3 and -4, what we'll get is here in dp min we'll be having 1, right? So -2 into -2, 3, and we have to also compare then this with dp max of I RTP min of I, we need to compare that. I don't know, this could horribly go wrong. Okay, it solved many test cases, but it's still failing. So looks like we have to reach out to the editorial. Rather than looking for every possible, let's read it out. Where is that? Rather than looking for every rather than looking for every possible subarray to get the largest product, we can scan the array and solve the smaller problems. Let's see this problem as a problem of getting the highest combo chain. The way of combo chain work is that they build on top of the previous combo chain that you have acquired. The simplest case is when the number in nums are all positive. In that case, you could only need to keep on multiplying the accumulated result to get a bigger and bigger combo chain as you progress. However, two things can disrupt your combo chain: zeros and negative number. Zeros will reset your combo chain. The high score which you have achieved will be recorded in placeholder result. You will have to restart your combo chain after 0 if you encounter combo chain which is higher than the recorded score and result. You just need to update the result. Negative number are little bit tricky. A single negative number can flip the largest combo chain to a very small number. This may sound like your combo chain has been completely disrupted, but if you encounter another negative number, your combo chain can be saved. Unlike 0, you still have a hope of saving your combo chain as long as you have another negative in nums. Think of this second negative number as an antidote for the poison that you just consumed. However, if you encounter a 0 while you are looking for another negative number to save your combo chain, you lose the hope of saving that combo chain. While going through the numbers in nums, we will have to keep track of the maximum product of that number. Yeah, and minimum product to that number. Okay, yeah, we did that. While going through the numbers, we will keep track minimum. uh, okay, we will call min so far. The number behind keeping track of max is to keep track of accumulated product of positive number. The reason behind keeping track of min so far is to properly handle negative number. Max so far is updated by taking the maximum value. Min so far is updated by using the same current number. This value will be picked if accumulated product has been really bad even compared to the current number. This can happen when the current number has a preceding 0. Product of last maximum so far and current number. This value will be picked if the accumulated product has been steadily increasing. Product of last min so far and current number. This value will be picked if the current is negative and the combo chain has been disrupted by a single negative number. So let's see this visualization. So -2, -2 minus 2 into -5. So -5 is greater. -10 and -5. 3 is when our current is 3, then max so far is 3 and minus 30. So current number, okay, current number is minus 5. Got it. Minus 2 into minus 5. Then 3, 3 minus 15 minus 30. So we are tracking so min so far is nums and max so far is nums. Result max so far. So we have to start with 1. Current num is num of I. Temp max current. Then mat dot max. Max so far into current and min so far into current. So result mat dot max. Max so far result. Okay, yeah, we are just keeping track of it. Why don't we just keep instead of temp max, why don't we keep it as max so far? Okay, but because it will get changed here. Okay, yeah, that makes sense. Yeah, so our logic was almost similar, but instead of this array, yeah, if just I would have used so let's see what they are doing there again. So here we have to take the current into so the minimum so far into this, okay, maximum so far and minimum so far, and okay, product of last max so far and current number and minimum so far and current number. So DPE, we don't have to use anything other than this, and we have to just keep track of our nums of 0, nums of 0, and here we start with nums, and first of all we find the max, dp max, or we call it temp. Let temp max let temp max and equal to mat dot max, and then number of I, the current number, and the math dot max dp min into nums of I dp min into nums of I and dp max into nums of I. So this is what we have to do, and we have to do the similar thing. But find minimum dp min and okay, let's get rid of this, let's get rid of this, let's get rid of this, and dp of max and dp of max is equal to temp max, so that we don't change the value of dp max when we are multiplying it here. And now if we run this, okay, yeah, we need to also change this. Let and if we change this, and we also got to check if max is equal to number dot min, right? Min safe integer, then send dp max or max. What? So we did follow everything right, and if nums dot length equal to 0, we should have returned 0. Okay, now it got accepted. Okay, got it. Um, Another question to be added to our list to be revisited, and yeah, this time we were closer to find the answer. Our approach was in right direction, but at the same time not in the right direction. It Yeah. So okay, guys, the time complexity of this is of n, as we have to traverse the entire list, and space is of 1 because we are not storing any array or anything of that sort. We are just using these two, which is of 1 time required. Okay, that's it for this one.